So I've recently gotten super excited about all the possibilities of using 3D printing to really level up my long-standing obsession with shoemaking. But I had a bit of a dilemma.
How do I get my real-world, physical wooden lasts into the computer so that the parts I model in 3D will be the right size and shape to fit the rest of the shoe that I build on the last? Today, I'm going to walk you through how I tried to solve this problem by using a little something called photogrammetry to make a 3D scan, and then how I cleaned up that scan in Blender to make a digital model of my last. First, some definitions. Lasts are foundational to many types of modern and historical shoemaking. The materials used to shape the shoe's upper are stretched and tightly molded around the last's curves so that the inside of the shoe exactly matches that shape. So the last fully determines the size, fit, and style of the final shoe. Soles and heels that are designed for a specific size and shape of last often just won't work with other lasts, and small variations in measurement can make a surprisingly large difference to the comfort and quality of the final product. So if I want my 3D printed parts to be wearable, I really need the digital last I'm basing them on to accurately mimic the one I'm using in the physical world. Photogrammetry is super cool. Basically, it's the wizardry of taking real-world measurements from photographs, or sometimes other types of sensors as well. If you're an elder millennial like me, you might recall being blown away by the behind-the-scenes extras on the Matrix DVDs about how they filmed the so-called bullet time sequences. This is where they arrayed about a bajillion cameras around the actors to create the illusion of them being frozen in time and space while the camera freely moved around them. A 3D effect can be achieved by using lots of cameras like this, or just one camera to take lots of photos of a static object from many different viewpoints, which is essentially what I've done here with the help of an app called Polycam. By viewing the same points on an object from multiple angles, an algorithm can triangulate where those points are in space, and then build up a three-dimensional representation of the shape and texture of the object. This technique has been around for a while, and I've even attempted to do some photogrammetry a few times before over the years. But until recently, the best software required some pretty specific hardware that I just didn't have access to, and a lot of the alternatives were not very user-friendly or effective for me. But recently, I've seen more and more mobile apps pop up, and I decided to try out Polycam.
By the way, this is not sponsored content, this is just the app that I happened to try, and I got pretty good results.
Having even all-over lighting is really important to getting a good 3D scan. So I took one of my lasts outside and propped it up in a spot where I could walk around it and get a good view from all angles. Once you hit the start button in the app, it takes photos at regular intervals automatically, so all I had to do was focus on moving the camera around to capture as many points of view as possible. Then it just took a few minutes to process before I could view and download the 3D reconstruction. This app does offer paid subscriptions, which unlock a few extra features, including extra file formats, but in this case, the GLTF file type available with the basic free tier was all I needed. Once I had downloaded that file, I opened up Blender, which is a free open source 3D modeling and animation software. It's very popular and very powerful, but fair warning, it also has a pretty steep learning curve. I started learning to use Blender about 2 months ago, and I've made a lot of progress, but I'm still definitely not an expert. So keep in mind that everything I'm about to show you is just how I stubbornly problem solve my way through this process, but it's not necessarily the best or most efficient way to approach it. First, I deleted all of the default objects in the scene, and then I imported my scan. The file does come in kind of huge, so I scaled it down to a more manageable size, and I set the origin to be in the center of the object to make it a little bit easier to do some manipulations. I then switched over to edit mode, and I deleted all of these extra vertices that aren't actually part of the last. Once I had cleaned away all the extra material, I then switched back to object mode, rotated the object so it's the right way up, and spent a little bit of time reorienting it so that it was nice and centered and that the feather line was well aligned to the axes. I then rescaled it to its real-world size. I happen to know that it's about 80 millimeters wide and 225 millimeters long.
Switch back to edit mode, and here I went ahead and made sure there weren't any overlapping vertices. I also filled in these holes using a tool called 3D Print Toolbox to make a manifold mesh. That means that it's watertight. If you were to fill it up with water, none would leak out. I switched over to the sculpting tool to just clean up some of the rough spots, some indents that I didn't really want there in the final digital last, and smoothed out some areas that were looking a little bit rough. I'm mostly using the smooth and inflate tools here, also the flatten tool a little bit. The key thing with the sculpting is I wanted to make sure that I wasn't removing too much excess material. I then went ahead and saved and duplicated my object so that if I made any mistakes in the upcoming sections, I wouldn't have to worry about losing all my progress. Here I'm just adding a new mesh, and I'm going to use that to retopologize. So that is where I'm going to make a much more organized and easy to work with mesh with a lot fewer faces and points in it. So I am just drawing around the outline of the bottom edge, capturing as precisely as I can that feather edge, but I'm just really doing a rough outline here because it is going to get smoothed out in a later step. I filled in a face and then inset those faces to get these sort of concentric curves, and I dropped an edge down the center. And then I just went in with the knife tool and I cut some faces across the center there. I tweaked things a little bit to even things up and added an extra little bit of mesh toward the outside edge. And here I'm adding a subdivision surface modifier as well as a shrink wrap modifier. So this is going to add some invisible faces, and the shrink wrap modifier is going to suction that plane to the existing mesh, and so it's going to match that shape very closely. I then cleaned that up so that it was matching pretty closely. And I applied both those modifiers before moving on. Once again, I saved my work and created another duplicate so that I didn't have to worry about doing anything destructive and losing progress in the next step. I selected that edge loop of the feather line and I extruded those vertices upwards. So this is going to cover the upper portion of the last. I tweaked all the individual vertices there and made sure that it was forming a nice smooth line around the outside. And then I selected that edge loop and extruded a new one out above it. And I just kept repeating this step of selecting, tweaking, extruding, and so on until I got all the way to the top of the last. I can't wait to get shoemaking with this new digital last. So if your interest is piqued and you want to see what comes next, don't forget to hit the subscribe button so you don't miss the next installment of these shoemaking adventures. And until next time, stay curious.